Hi, this is another SQL lesson from Learning SQL on PostgreSQL, which is my book. This is from chapter 4, and we are going to be focusing on inner joins. So this slide shows you what inner joins are. They're the most common kind of join. They return only matched records. That usually means the primary key from one table is repeated in the other table as a foreign key. It does not return any unmatched records. This is just a curiosity. I have the chat now with Bing, and I'm going to ask, describe a SQL inner join. Or maybe instead of describe, let's do it define. So this is the chat GPT as Bing uses it. So notice it has an inner join as a method used to combine records from two tables based on the fact that they share some common value. It creates a new table by combining rows that have matching values in two or more tables based on a logical relationship or a common field between the tables, and is used to retrieve the data that appears in both tables. And it does give some references, so that's not bad. That's a curiosity. That's really not the main part here. Let's go to PG admin, and let's do using again Community Assist, which you can get if you go back to the earlier videos. It'll talk to you how you can get it from GitHub. I am going to do an inner join between employee and person. And we'll build that out for a bigger join. So I'm going to do select person last name, person first name. Let's look at job. So when we look at employee, there's nothing there except the employee key. So let's add employee key up here. I like it first. All right, so this is from two tables. I'm going to say from person, and then I have to say that there's an inner join with employee because we're getting it from two tables, from person, inner join employee. You could reverse these two. You could say from employee, inner join person. It would be fine. And then I have to say how they relate. On person dot person key equals employee dot person key. All right, so this is the primary key in person, and it's a foreign key in employee. And that's how the two tables relate. All right, and so when I do that, it gives me a list of all the employees and their names. We could order by the employee number if we wanted. And then they would be in order. Okay, so that's an inner join. There are other ways to do this, but the word inner join is generally the preferred way. Join without the word inner works exactly the same because it is assumed to be an inner join if there's no designation. All right, so let's look. We might want to know what the positions that the employees have. So I'm going to add something to this. First, I'm going to copy this just to keep from having to type it all again. And I'm going to add another inner join. And this time what we're going to do is we're going to inner join with employee position, because it tells what position each employee has. On employee key equals employee position. employee key. Couple of things. Let's add some fields that we want to look at. So if I look under employee position, there's employee position key, and there's also employee position start date. Let's just get the start date. Well, we'll do employee position key, and then we'll do employee position start date. Okay, I'm going to break that line. That should work. Okay, oh, this is a good thing to show. Employee key is now present in more than one table. So we need to say where we want to get it from. In an inner join, it doesn't really matter, but it does. It needs to have it designated. And there we go. So we have the employees again. Notice Lynn holds several positions. And we have the date that they were started, and we have the key. But it would be nice to know what that actual position is. So let's substitute, instead of the position key, the employee position key, we'll do the actual position name. So again, I'm going to copy this. And I'm going to, instead of position key, I'm going to do position name, which is under job position. So position name, which means we need to do another join. We need to add inner join job position. And we need to say how that's going to relate. And that will be on position, job position, position key. Equals employee position dot job position key. One of the things, if you read the book, it'll tell you how to abbreviate some of these so that it isn't quite such a pain to type. But I'm not going to do it here. When I run that, okay, job position does not exist. That's because I spelled it wrong. And now it should exist. And we have their employee name, their position, and the date that they started that, which is a readable table. We had to get 4 different tables information to get that readable description of an employee and what positions they have. All right, but that's what joins do. Inner joins can bring all that information back. All right, I'm going to show a little bit of an inner join with an aggregate function, because this is also an important use of joins. And then at the very end of this, I'll show you a danger in doing this. We're going to, first of all, we're going to look at the all of the grants, but we want to know their names, and we want sums and averages. So I am going to do select, and I'm going to do the date. I'm going to do, remember this function? I'm going to extract year from, let's look at grant application, from grant application date. And I'm going to say as year, okay, comma, and then we'll go down to the next column, which will be grant type name, right, which comes from grant type, a different table, and then we will do sum grant application amount as total, and then we will do average grant application amount as average. And let's just for good measure do a count. Well, let's see. Let's do it as count. All right. So I'm going to do from grant applications. But we also need to do an inner join to get that grant type name. And we interjoin with grant type. And we do that on grant type dot grant type name equals grant application dot grant type name. We also have some other problems which you might remember from before, in that we need to join, or we need to group by the year. So let's copy that function. And we need to group by grant type name, because neither of these are aggregate functions, they're row by row things. And then I think we'll do order by the date, the year. Okay, so this is an aggregate, using an aggregate with a join. It's the same as using an aggregate with other things, with single tables. Except you get more information. Oh, I did a period instead of a comma. It's good to be able to troubleshoot these real quickly. Grant type name, grant application. Oh, I left out the word on. That should fix that. And now what? Group. Oh, no comma there. Commas are going to be always your main problem. Oh, and you don't repeat group by. You just put a comma there. That's why there was. You just list the things you're going to group by. Now what? Order by. How did that get in there? And where did I do grant applications? This is a lot of troubleshooting that I didn't mean to show you. Oh, and then again, it's grant type key equals grant type key. That was a lot of work for nothing. So basically we have, it's ordered by year. We have each of the types that comes from the type table. We have the total that was asked for in each of those years. And then we have the average that was asked for in each of those years. And we have the number of requests for those. Now you could format this more and make this prettier. I think I will skip that. But that gives you a join with aggregates with sum, average, and count. I'm going to do another one, but this one comes with a warning. Oh, come on. So I'm just going to put here okay, so let's take a look at this. I am going to, let's say we want to know how many donations come from each city. So I am going to do select city name. I think it's person, address, city. And I'm going to do sum donation amount. Now there's no direct link between person, address, city, and sum donation amount. I'll just do this as total. All right, but I'm going to do it from, we'll do from person first, because that's where the relation will happen, from person. Inner join person address. On person dot person key equals person address dot person key. Inner join donation on donation dot person key. I'm reversing it here. Equals person dot person key. It doesn't matter what order you list them. So let's do this. That's donation amount. All right. Oh, I need to do group by. Need more coffee. Group by person, address, city. Okay. Null means that no city is listed. There's $250 by somebody that never listed a city. The other cities we get Bellevue, New York, Seattle. I'm going to, I think, bring up a calculator. All right, let's add up these. There's 250 plus 950 plus 350 plus 750 plus 6150 plus 2500 plus 62,020, 62,020, 45. I think I actually need to, that's right, 6202045. 62020.45 equals 72,000 970.45. So let's test that by just doing select sum donation amount from donation. Notice that it's different. There's 69,244.95. So let's bring back the calculator and say minus 69244.95. There's a difference of 3,725 and 50 cents between those two listings, between the two sums. The reason for that is because there are some people have more than one address, and so they'll get counted more than once. They'll get counted for every single address. And it'll creep in. There'll be extra values there, 3,725. But in a really huge database, where a lot of people had a lot of addresses, you would get a very false value here, and you might not be aware of it. When you're doing aggregates with multiple joins, you have to be careful that there aren't accidental duplicates that creep in. I just wanted to mention this as a running danger with these. You need to be careful, especially if it's very important that your sums are correct. All right. Next time we'll do outer joins, and I think this will be, I'm going to let this video stand even though it has a lot of corrections and a lot of troubleshooting. All right. So enjoy. Hopefully this will be useful to you.